Hello, everyone. Welcome once again to the second technical session of the community air quality practice that is organized by WRI Mexico. My name is Ana Cecilia Perales, air quality coordinator on WRI. This session is called Reference Net Monitoring Networks versus Hyperlocal Monitoring Networks, Accreditation Process by National Entities. And this has a purpose of sharing with the community what are the differences in terms of quality and data quality assurance between the reference monitoring networks versus the hyperlocal monitoring networks with the use of low-cost sensors, and what are the accreditation methods on the monitoring reference networks. We will have a couple of speakers that will talk about quality microsensors. We will also have the presence of the AirQo air program, the Okure, and we also have the director of the Ministry of Environment. At the middle of the session, we will have a Q&A session that will be moderated by Dr. Tania Lopez. And then we will continue exchanging experiences in terms of air quality from the Ministry of Environment of Bogotá, also Guanajuato, and an external entity to the government. Finally, we will close off with an exchange of opinions and comments by Dr. Beatriz Cárdenas. Now we can get started. We will move on with Armando Retama's talk. He has more than 20 years of experience in issues related to air quality monitoring and has collaborated in multiple projects in the private and public sector. He was in charge of the operation of the atmospheric monitoring system in Mexico City, and he will be sharing different methods to ensure air quality data. Go ahead, Armando. Thank you so much, Ana Ceci, and thank you, WRI, for the invitation. Those who live in urban areas, we daily face the impacts of air quality. We see the impact in our own health, our family, and quality of life. And we understand that there are some measures that authorities take to reduce the damage and also to reduce impacts by certain standards, by the follow-up and implementation of policies. And all of this, in all of these processes, monitoring is a very important piece because we can get quantitative and informative information around pollution, but also about the positive or negative impact of the actual policies being implemented. Now, the issue of getting reliable data, it's a very important question. We have very precise, accurate, sensitive instruments that need to record the most exact data possible. And there should be a program and people qualified behind all of this monitors in order to ensure the correct use of the same. Now, if we move to the next slide, we see that this information comes from monitoring stations. These are stations that provide data, which is absolutely necessary in terms of air quality assurance in order to take decisions around that. However, this data can also be used as a reference to compare against other alternatives for air quality monitoring. However, monitoring is not cheap. It is actually quite costly. The average cost goes over $100,000, sometimes $10,000 in terms of monitoring stations. Now, if we talk about a network, you can see what are the limitations in terms of funding that will be in place. Now, this cost cannot be compared to the effects of pollution, actually, but there are some regions and cities that do not have the necessary resources to install monitoring networks. That is why in the next slide, we can see that when we see these low-cost sensors or sensors that are used for other type of stations, looks as a very promising procedure. The fact that we can monitor air quality at a fraction of the cost of a whole monitoring station, this opens a lot of possibilities. As we can see in the next slide, these devices are based in very low cost sensors that cost between $10 to $100, and they can be used to create devices, as we can see in the following slide, to monitor air quality indoors and also other monitors that can be installed outdoors. These are being used as a complement of monitoring networks as well. Likewise, this is also do-it-yourself approach that we can use. If you have the necessary programming knowledge, you can also create your own devices and generate very similar devices to the ones that we can see in commercial devices. This is a paradigm shift in terms of monitoring. Currently, data is generated by governments with very specific purposes. For example, evaluate standards, to follow up the trends, and also for research purposes. And it's the government and researchers who determine which data we have access to. Now, with this type of devices, anyone could do monitoring of air quality. Data now is open to multiple options. There are several devices that can be used online and are open source. And now in terms of more professional terms, for those who work in monitoring in a more serious way, this also opens a lot of possibilities in terms of creating monitoring networks with a very high spatial density. We can also mount them on drones so that we can have actually a bigger area being monitored in this way. And the advantages of these devices is not only the cost, but also the size. These are devices that are very portable. You can install them in some areas that it would be very difficult to install a monitoring station. These are not hard to install. You do not need or require any kind of precise knowledge or advanced knowledge to install them. And data is available immediately once it's installed. However, there are some cons around this or disadvantages. On the one side, we do not know how accurate this type of data is. Sometimes sensors that are in the same area can have different values reported. Commercial devices have an algorithm that the normal citizen doesn't have access to that allow to correct for these differences. Also, there are some interference in terms of how the data is being measured. There are some other unknowns as well. It is not possible to calibrate these sensors. So when we talk about some of these commercial devices, we do not have the data properly. We need to look for them and then download them. So these are some of the disadvantages of these devices. However, despite all of this, we have many applications. For example, we can use them for education information. We can identify hotspots. We can see, for example, the variability of pollutants in a specific area. We can also monitor personal exposure. We can also have an exploratory monitoring to supplement monitoring networks. And there are some attempts to use these as regulatory monitoring efforts. However, when we talk about this type of applications, we need to think about the quality of data. This is a critical point. We need to use this data for decision-making or for some applications that could have some legal implications. That is why we need to understand the uncertainty of measurement of these devices. So we see here some of the applications in terms of the accuracy that is typical, that is recommended for this type of devices. So when devices are related to awareness creation or education, we just want basically for the device to report whether the pollutant level is high or low. That would be enough. However, if we want to use those devices for an exploratory monitoring, in that case, it is important for this data to be as closest as possible to what reference stations are reporting. And if it is actually going to be used for regulatory monitoring, the sensitivity of these devices need to comply with an equivalent of the reference measures. And currently, this is not possible, or this is not what these devices are actually reporting. Now, putting this into the geographical context, the air quality of the Latin American and Caribbean region is sub-represented, underrepresented by monitoring. That is to say, these monitoring stations are very focused on urban areas, and there's many cities, small to medium size, that lack this type of air quality devices. That is why some environmental agencies are looking into these low-cost options. And this is a really good question. Can these devices replace other type of devices? I would like to illustrate this with this example in Mexico City to answer that question. This is in August 2021 data with a device that costs around $300 that is being used very frequently around the world. You can see these wonderful maps that you see in your computer versus a reference device with an API T640 that costs around $300. So it is very, very interesting how this sensor is capable of reproducing the variability of pollutant concentration quite accurately. However, if we go more in depth in the analysis, well, I don't see the data actually here, but there was a comparison between these two data. Perhaps you will be able to see it in the presentation that we'll share with you. So what we are supposed to see in this graph is that during rainy season, we underestimate the concentration of particles. However, when you compare this with February 2022 in the dry, cool season, you have an estimation of this pollutant. There shouldn't be, purple air is not capable of identifying concentrations under 4 micrograms. And there is a very different or very significant difference between what this type of climates are able to report. Now, this is another example in terms of ozone. This sensor that we're using here is a DF robot for ozone. We see, for example, some interference that could be NO2. This would not be very useful in order to monitor a greater length of time for ozone. So when the quality of data we need to understand it's extremely important. So if data is, the quality of the data is unknown, and we need to use that for decision making or important policy implications, it is preferable not to have any data than to have the wrong data, actually. That is why we really appreciate the work that several agencies are doing, that they are evaluating the performance of these sensors. For example, EPA, as we will be able to see in the next slide, has published protocols to evaluate these devices. Now, with this information, some cities have taking the steps to compare performance of the different devices, as we can see, for example, in these publications. In Mexico City, they have just started a campaign. They are comparing various sensors with reference equipment. And in other cities, they are using this in order to determine whether these devices will actually be useful in the local context. Now, thanks to the work that is being done around this, we know that it is possible to establish a quote-unquote calibration of these sensors. This calibration can be used or can be done in the lab using different mixes or by means of a comparison of reference devices on the field using different methods. I will not go into in depth around these methods, but you will be able to read them in the presentations once I share it with you. Now, we are considering to use a network with low-cost sensors in order to supplement the monitoring load. Now, it is important to understand that we need to calibrate them. We need to do an adjustment and correction of the data. And this can also vary in terms of the weather and in terms of time. So we need to identify these differences in the sensors and try to correct for that. We need to implement quality control assurance in order to make sure that the operation is actually smooth and the quality of data is precise. We need to have methods to analyze the data if we are considering to not use the platforms that the manufacturers use. So we need to have a continuous communication with those sensors and to have the equipment and the actual personnel, staff that knows how to use this data and how to use these sensors. Now, if we place all of this together, even though we might be using low-cost sensors, our networks are not necessarily low cost. If we see, for example, in the next slide, thank you. So we need to be certain that in the future, this monitoring will be done with hybrid networks. These are hybrid networks that will integrate the measurement of sensors based on satellite platforms with the information coming from low-cost sensors. This will allow us to increase the spatial scales and temporal scales as well. However, it is very important to acknowledge as well that satellite data and the data coming from these sensors or any other low-cost device will require the use of monitors in our stations for a regulatory purpose. So the first step to implement or to install a low-cost sensor network needs to be the installation or the reinforcement of the monitoring stations, because that will allow for the necessary information to normalize the data coming from different sources. So some takeaway messages from this presentations are the following. There's a lot to discuss around this issue, but let's just take this home. We need to say that sensors are very, very important to educate and create awareness for the population. There's no doubt about that. These sensors allow us to obtain information for high density space and time, but we need to be very, very careful when we use this data. We need to use them in combination with reference instruments in order to use actually this data for specific purposes in data management. We know that these sensors are far from replacing the regulatory monitoring sensors, but I believe that the improvement in technology in 10 years' time, I believe these sensors will be able to generate more accurate data. And also in the future and currently, we will continue to use our reference monitoring stations for the calibration that it's needed for microsensors measurements. And very, very important is that before we go and do this in terms of a network, we need to consider that costs can be quite important here. They can be quite elevated, similar to the ones that are being used for regulatory purposes. Thank you very much for your attention. Thank you, Armando, for your presentation. Now we will pass the floor to Dio Okure, for Air Quality Scientist Program Manager of AirQo, by means of low-cost sensors in Africa, Sub-Saharan Africa. Thank you so much. Dio, please go ahead.
Yeah, thank you so much for the warm welcome. My name is Theo, has already been shared, and working with AirQo, based in Makerere University, Kampala, as the research group. So I'm going to share the previous presentation, obviously, sets the stage for what I'm going to be sharing more in depth in the form of a case study. So I'll be sharing about how local sensors can actually be adapted for sustained monitoring to close the qualitative gaps in Africa and the Global South from our experience as AirQo. So firstly, it's important to understand the scarcity of air quality data in the Global South. And by air quality data, I'm referring to ground monitoring. What you see, if you look at the monitoring landscape in the world, you see that the Global South and Africa in particular has got very limited data sets in terms of ground monitoring. So how can we effectively close these gaps? And we are saying that local sensors provides an opportunity for closing the air quality data gaps more cheaply. But of course, I'm going to quantify, give a bit of more context of what entirely raw cost means. So that's kind of a zoom in of the map on the left, on the right rather. It's the network from AirQo. So what's the case for low cost monitoring? Firstly, it's very expensive to set up a monitoring station. The cost of an air quality monitor as standard could go up to $50,000 or even more. And if you want to have a high resolution network, it is impractical for a resource-strained country, especially the countries in the Global South. And yet we need a high resolution network for effective management. Next slide, please. Yes, next slide. Yeah, so looking at AirQo as a test case for sustained monitoring, how we are adapting these local sensors to close the air quality data gaps in the African continent, not just in Uganda. Next slide. So briefly about AirQo. AirQo is a research initiative based in Makerere University, Uganda. And what we do is we are leveraging the advances in low-cost innovation and technologies to close the quality data gaps. And how we do this is we build local solutions to support air quality management. In other words, we believe in building solutions closer to the problem. So we are building low-cost devices the devices in Okure, and then working with communities to collaboratively deploy these networks in different urban spaces to give us a sense of, to quantify the scale of air quality, in the scale of air pollution in urban spaces in Uganda and the African continent. And so far we've deployed over 120 low-cost devices. And that's a growing network. Next slide. So these devices, of course, are deployed collaboratively. And one aspect of the work, of course, is to ensure that we're also engaging policymakers to make sure the data that we collect is actually used to inform policy. So that's a bit of a snapshot of the different stakeholder groups that we are working with. The city government, the development partners, the foreign missions and diplomatic missions in Uganda, and other academics, etc. Just to, because air quality, it's cross-cutting. And it's important that we bring ourselves together to be able to work together to find sustained initiatives to improve the quality of the air. So that's just some bit of like highlights of the work we do. So what you're doing is basically monitoring and also providing engagement. So we have the technology in terms of the innovation and the infrastructure, but then making sure that data actually makes sense, then it speaks to the decision makers. So that's a big part of the work that we're doing. Next slide. Yes, so I want to spend more time here in terms of sharing experiences, really like digital platforms where we leverage artificial intelligence and computing capabilities for effective data management and awareness. So I think like the previous speaker, like Armando said, you sort of have low cost is a bit more elaborate than just the device. You need to look at the cost of air quality monitoring more holistically, more broadly. And of course, in our setting, the digital platform that has been very effective for public engagement is having a mobile application where we, locally developed a mobile tool to kind of inform awareness, to inform for public awareness. So from a technical side of things, so the local devices are prone to failures. We need to be able to actually manage them. And how do you, could you have the previous slide? Thank you. There. So we built a dedicated dashboard to monitor the network, the physical deployment. And what are we interested in? The metrics. We're looking at, we have a network of 120 devices. We have to be able to know at any one time which device is actually streaming data and which devices are underperforming and why, trying to understand why. So using the platform, the computing platform, as an avenue to troubleshoot, to effectively manage the network. Because, and then this is quite costly as well, but then just to be able to bring out the aspect of knowing that this is an actual cost driver. But then if we are to make the low cost data sets work for regulation and for awareness, we need to put in place all these infrastructural details. Yeah, so beyond the data, the network management platform, we of course also have the dash. How do we make the data accessible to non-expert users? The policymakers might not have coding or programming background or data scientists, but then they would want to very much, of course, understand, ask the basic question, and get answers. So we're trying to empower the policymakers by developing a dedicated dashboard where they're able to actually perform their own analytics without necessarily having to have, because you're talking about millions and of rows of data. So how do we then empower them? So this is kind of what informs the intervention, the innovation, to have a dedicated dashboard that is able to provide, the interface will provide data analytics to the policy, to the non-expert users. Next slide. Yeah, so, okay. Yeah, I'm going to talk specifically about the calibration. So the infrastructure setup is that you have a network of 120 devices. So the question of will the low cost sensors eventually replace the reference monitors? Maybe at some point, but at the moment we see the two approaches working side by side to the extent that we need the reference monitors to support the quality control of the low cost sensors. And in our case, we're using two reference monitors to set up a permanent co-location infrastructure where we develop a calibration model and then use that to apply to the network in Kampala and Uganda. So the two reference monitors, that's a BAM 1020 and 1022 for PM10 and PM2.5 to be able to support the calibration of the rest of the network. Next slide, please. And this is what our calibration pipeline, field calibration pipeline looks like. But of course, it's important to mention that we develop our own monitors at the university, and the calibration starts right from the quality control starts right at the university, where we have some metrics before deployment. Before a device goes for deployment, we know that we have to do some laboratory environment kind of co-location deployment, where we monitor the correlation intra-sensors. The AirQo monitor has got each AirQo monitor has two sensors for each parameter. So if it's for PM2.5, we have sensor 1 and 2 as a way of monitoring the performance. So if sensor 1 and 2 do not exactly agree, it means there's a problem. So we use that kind of flag and anything for any corrective measures to be taken. So before deploying that, we have these metrics that we put in place. And also, of course, do the devices actually agree with each other before taking them to the field. Then once you take to the field, then we have this pipeline, this workflow, where we have the data collected through GSM module, and then onto the database. Then we have the calibration performed. We retrain the model, of course, monthly, and then have that data calibrated. And then, but more interestingly, if you go to the next slide, please. Yeah, is that, of course, this is some of the insights of how the performance of local sensors in Uganda versus other geographic settings. So this is from the UNEP, where they're trying to evaluate the local sensors deployed in different parts of the world, and Kampala being one of them. So you could see we're using plant-hour sensors, and of course with the infrastructure built locally to withstand the settings, that withstand the unique challenges in the African continent, where the logistics and also the physical environment. So of course, in our case, we're using the random these two calibration models. that then ultimately eventually improves the calibration, the correlation of the data sets by up to 0.9897, and having it cross-validated on a monthly basis, so that we are able to, with this fixed infrastructure, we are able to always cross-check and make sure that the calibration model is up to date. And this is a clear test case for other, for other cities in Africa and beyond. Next slide. So what's really important is to treat the calibration as a product, as a reusable product. What I mean is that it's not just for ourselves, but then we recognize that there are other emerging initiatives around different cities in Africa. So how can we support people who might not have access to a reference monitor? How do we support them to calibrate their 2-3 sensors? So we have this public user interface from the calibrate model, where you are able to actually upload your own raw data sets, and you can be able to calibrate your own data by yourself. So it's kind of packaging the calibration model, or the calibration as a usable product that will eventually support other research groups. So that's kind of the approach that we're exploring, so that in the end, we are complementing whatever is happening in other cities. And I think this is something that is very scalable, that could eventually could actually be replicated in other cities. So the other thing is that, of course, opportunity as well to leverage the platform as a one-stop center. What that means is that we can actually, having all the different initiatives, one major challenge is how do we store the data, how do we access the data? So we have this computing platform through our technology partner, Google, to be able to have integrate all the other local sensors, where it's easier for people to access the information from one place, and also amplify the impact of the work that you're doing, so that in the end, whatever the communities of practice, we're kind of complementing each other as opposed to duplicating efforts. Next slide. Yes, I'm going to just summarize some of the implications from the experience and maybe lessons for, So one thing is that, of course, when it comes to the low-cost sensor network, we know that routine maintenance is very important. And I guess this is also the same thing as the reference monitors, is that we need to be able to maintain the network more routinely. Maybe what varies is the cost of the maintenance. It's probably lower, but it's important to factor in the cost of the maintenance and not just look at the cost of the firmware, because it's really important. If you're to get data to ensure data, guarantee data integrity, you need to be able to routinely maintain the network. Power optimization, of course, is becoming interesting and increasingly really important. And to the extent that in the case of Africa, you find electricity connectivity is oftentimes very unreliable, and yet having a solar optimization, which we actually do at the moment, won't exactly guarantee 100% availability. So how do we, there's lots of opportunity to research around how we can optimize the power usage for the device so that you are able to have at least 100% data availability for a given day, because certainly power is becoming a challenge. So the dual sensor approach, of course, is quite unique, maybe to AirQo, is that it's been very helpful in terms of flagging some of the disparities in the data, because we're able to know that if the two sensors do not actually agree well in the field, then that's already that's a warning, that's an opportunity, that's a call to go and take some action in terms of the maintenance. And then from of course, the uptake side of things, we have an initiative to where we physically engage the data users. We try to train them, we provide hands-on training to the data users, and data users looking at the policymakers from the different spheres, from their different government agencies, the academics, and also other stakeholder interest groups, where we actually give them actual hands-on training to be able to actually access the data. So that way we're able to actually increase uptake. So if you're going to push for uptake of this, the decision makers, people who make decisions, we should make them see the value in air quality. We should make them see the value in the local sensor data and also the potential. But if they don't appreciate the potential, it will probably be very difficult to have, push for the uptake and also make a case for adoption of local sensors as supplementary, as an initiative, as a solution to the limited data sets that we have in Africa and the Global South. Next slide. Yes, thank you so much. That's the end of my presentation, and I welcome any questions. Just some of the active collaborations that we currently have. Thank you so much, and welcome to continue the conversation on our media platforms.
Muchas gracias, Dio, por
Thank you so much, Dio, for joining us from Uganda and sharing your experiences with us. So let's continue with our last speaker. Now I would like to give the floor to Olivia Rivera Hernandez, who is the Air Quality Director of the Ministry of Environment in Mexico City, and she will be telling us about the procedures and accreditation processes from SEDEMA, which is the Mexican Accreditation Authority, and she will also tell us about the quality assurance and control of data. Thank you so much. Thank you so much. Welcome, everyone. And I would like to thank you for the invitation. Before continuing, I would like to tell you that this presentation has two sections. One of them is understanding what is the reason of being for quality air monitoring. And based on this, how do we build the monitoring system and quality assurance systems? And the second part has to do with the requirements that monitoring systems must comply with in order to ensure the quality of the data we're offering to the population. Please go ahead. Well, as you all know, in Mexico, we have the Environmental Ministry and Natural Resources, which is the entity regulating environmental policies in Mexico. So this regulation is given in the general law of the green balance, which is established for all the entities and cities, or all the entities and cities that have an established environmental verification systems and air quality monitoring, implementing mechanisms in order to restore and correct air contamination, soil contamination, and the environment in general. And this general law of the ecologic equilibrium has 7 rules, and one of them is for air quality monitoring. So in order to address this request done by Semarnat, we have the air quality guidelines, which state which are the pollutants that we should be measuring. But these are not the only ones, but these are the basic pollutants. And we already know that there is some that are harmful for people, such as ozone, NO2, fine particles that should be less than 10.5, and lead. But these guidelines depend on which is the view they have for the regulation in terms of environmental management. And in the case of the US standards, they have a primary standard to protect the health of the population and a secondary one for protecting the environment. And in the case of the WHO guidelines, they have as a standard for acute exposure, which are the indicators at a short term, and standards for chronic exposure, which are standards that are annually assessed. In the case of Mexico City and in the case of Mexico itself, the standards that we are currently using are similar to the ones presented by the WHO. Before, we were focusing a little bit more on standards used by the Environmental Ministry of the US. And part of being able to plan our policy for measuring air quality is that we need to know what is it that we have in the environmental area. And besides of the criteria, contaminants that we know that we have certain concentrations due to the climate season, because in the Mexican Republic, we have very well determined the different weather seasons, but we also have an impact due to the climate change situation. It is known that ozone and the particles have been increasing according to the way the annual temperature increases around the world. So we also need to take this information into account for our policies in order to do the air quality monitoring and being able to do the quality and control assurance. And this program state that they need to be assessed continuously. And what are we going to be evaluating for air quality monitoring? Well, all of this regulatory actions set by governments in order to improve quality of air. We have the standards that were already selected, and now we have the policy that will improve, or we're intending for this policies to improve the air quality. But for this, we need to use monitoring continuously on a routine basis and supplementary to all of this policy. So this is not just a part of, it's not a tool from, this is part of a policy for air quality management control, just as the policies that are set for the emissions of vehicles. So in this new scheme of policies, the cities have what we know as pro-airs, the quality control programs. And in Mexico City, we have just published a recent program, our latest program. And somehow this is linked to the needs that we have as a government and as a city. And we need to have information linking air quality and health. What does this mean? Well, this is through providing the air quality rates in an accurate and reliable way. And we do this all the time. And we also need to research the processes controlling ozone and fine particles. And Mexico City monitors all the particles, but we have an issue with all of the secondary components, which are the ones that are predominant in the Valley of Mexico. We need to focus our efforts in order to reduce the emissions of the precursors of particles and ozone. So next slide, please. So by knowing all of this, we plan the creation of the atmospheric monitoring system. In the case of the Valley of Mexico, we have around 30 square kilometers of surface inhabited, and therefore the distribution of our stations cover almost the totality of the population living in the Valley of Mexico. We have an automatic network that provides us information minute by minute with 34 stations. And since we have some problems with particles and ozone, thus all 34 stations measure ozone and 28 measure particles. And we have a manual network providing information on the makeup of these particles that are in the environment through some later analysis. And we also have a network for atmospheric deposit and knowing what is the impact of the contamination. And we also have the meteorology network to know how these contaminants are being scattered in the basin of Mexico. And obviously all of this information is collected in the Center of Information for Quality, Air Quality. And this is also information that we share in social media so that we can inform the population about this. And we have a laboratory for the calibration and maintenance of the devices, but also to measure other species that are not within the regulatory framework. And this is in order to know that atmospheric chemistry that is causing this formation of secondary elements in the atmosphere. And we also have a data center in order to somehow streamline the dissemination towards the population and the processing of so much information we have. Let's continue, please. And in order to do so, in Mexico, there is a regulation stating a guideline for us to establish some air quality monitoring stations. So the standard 156 Semarnat 2012 defines the criteria in order to identify where should we create some air quality monitoring programs. And because of the specification, it provides the specifications for the design, establishment, operation, and maintenance of the air quality monitoring systems. It fosters schemes for the management, insurance, and quality and control for monitoring systems. And it provides the foundation for quality data management. And it also establishes a scheme of evaluation of conformity. So this standard within its requirements asks us to place monitoring stations, but for us to know how to orient these monitoring stations according to the parameter that we will measure, according to the time when these measurements will happen, the way the measurement will be done, knowing the representativity of our monitoring stations. And it also asks us to have an analytical laboratory for the calibration and the transfer of the patterns of our devices that are in the stations from the primary standard that may be national or international. And it also asks us to have a responsible area for operating the monitoring network that has the routine procedures for evaluating the devices that we have according to the instruments that each entity has. And this is a tailor-made suit because not all monitoring systems present in Mexico operate the same types of equipment, and we don't operate the same way. So it will depend of all of this that I just previously mentioned, the way we create our station and the way we create our quality assurance program. Also, this standard asks us to consider within the data analysis, which will be the criteria for us to establish our accuracy, our bias, our representativity of the data that we will have in our monitoring systems, the way we will assess the conformity of the current standard. And all of this leads to establishing this documentary requirements requested by all the systems for quality and control assurance programs. And next, we will see how the compliance or the assessment of this standard is being done by the Profepa. And this is within the regulatory policy of Semarnat. However, the Profepa doesn't really have the attribution or the knowledge in order to assess the performance of our monitoring stations. It may assess the documents that we generate and that the standard requests, but not the way in which we're complying with it. Therefore, from my point of view, we need to establish or broaden the field of application of this standard so that it's not just a matter of what's written down, but what we're taking to the field for operating the equipment that can be expressed or manifested through an audit. Next slide, please. We also have other models in order to implement our quality and control assurance program. The Environmental Protection Agency of the United States, or EPA, mentions as the first point that we have some air quality standards and we need to assess them. And to do so, we will generate information regarding air quality that serves for emergency control and to report the air quality rates or index, and also to evaluate the normativity and the trends of air quality. And with this air quality data, do research, and all of this will serve in order to propose control strategies as well as programs for implementing contaminant mitigation plans. And basically, this is the same scheme that we're using in Mexico City. The only difference is that all the documentation we have is focused on ensuring that the data that is being generated is reliable, accurate, and timely. And from the first level of validation from the information, and this deals with the operation of the instruments. We cannot wait until the data came from the equipment and we have it in the center of validation to say if it's good or bad. So we need to validate this from the operation of our equipment and the standards that we have. What is the reliability of the data? Next slide, please. So the Agency of Environmental Protection establishes which are the objectives for the data quality. And in this case, this chart shows the options for quality assurance for carbon monoxide, mentioning how often should a verification be done, how often should a calibration be done, who needs to do it, what is the uncertainty in order to validate that verification or calibration. And this will give us the certainty that from the moment that the data is coming out of the instrument, it already has a level of certainty in order to inform the population. Next slide, please. So, with regards to the scheme of the EPA, it's not just a matter of doing the assessment through all of this documentation they request. It's also the assessment of conformity through what is being generated with the monitoring networks. And this is done through audits. A systems audit done by the US or by a US or American agency includes documentation. It includes the audit of the data for this data to have the right flags, that for them to be classified as valid or invalid. And if there are some spikes, what is the reason of that spike? And for them to be accurate and precise, and for them to have all this type of information. And I repeat, this quality and control assurance programs are based on what we have in each of our regions and cities. Now, to supplement this in the next slide, we also have another model to ensure the reliability of data. In this case, the ISO 17025 standard has the objective of having the collaboration and reliability and trust from laboratories in order to prove that they're operating in a competent way and that they have the capacity to generate valid results. And at the same time, it's also based in other two international standards, which is the international CAP, which is the NMXZ 055, and the evaluation of conformity, which is MMX 17000, where the evaluation of conformity is the cherry on top, telling us how well are the monitoring systems working. So for the case of air quality monitoring, we need to have a gas certified systems with a photometer, with a primary pattern, with some flow calibrators traced in primary patterns, and all of our methods are documented. So this, once we have decided somehow through some scheme of control and quality assurance like the ones I just presented, which are not different, they're actually supplementary. It's just that some of them have more requirements than others. So it's a matter of taking it to an accreditation process through the Mexican accreditation entity. So the accreditation pertaining to air quality monitoring systems is the accreditation for a trial lab, where we need to ensure that the data that we're delivering have a technical competency, are reliable through performance
El tiempo se acabó,
trials.
perdón.
I'm so sorry, but you ran out of time. Yes, I'm sorry. This is my last slide. And well, this is where we need to evaluate and comply with the requirements in order to get the accreditation before the agency. Thank you so much. Thank you so much, Olivia. Thank you for sharing that experience from Mexico City. Next, we would like to go to the Q&A session that will be moderated by Dr. Tania Lopez. Please go ahead, doctor. Hello, can you hear me? Yes, we can. Okay, great. Thank you. Hello, good morning, everyone. It's a pleasure once again seeing you all. And well, as you have been seeing, the connecting thread of all these discussions has been what deals with the quality and control of air quality. And why did we want to do this emphasis? Well, because we think that it's really important to have information, as Olivia was mentioning, quality information that's reliable, because this is the information that is used for the management of air quality. I would also like to mention, and I would really like to thank the speakers because of the amazing presentations they made. And I also believe, or I have a question that is aimed at Dio in terms of this dashboard that you were showing us that you use in Uganda in order to provide information both for the population and the policymakers. I thought that was a very interesting dashboard, which is a way to publish or create information for decision making institutionally and individually. So within the model you have for quality assurance, does this model really does this quality assurance automatically? I mean, when you do this information assurance before getting to the dashboard, would you tell us something about it, Dio, please?
Yeah, thank you. Yeah, that's a really great question. Yeah, so the quality assurance is, of course, automated. So we have the we have the calibration model already deployed on the network. So in the data pipeline, if you could, I don't know if it's okay to share the screen again. In our data pipeline, the access data access is at the tail end. It's at is the last part. So all we have the network, the deployment, the physical network, and then data coming to the IoT data stream. The data is processed. We have raw data storage, and then we have the calibration in between. So as part of the pipeline, we have data access is the last step of the data pipeline. So by the time the user is accessing the data, whether in raw form in terms of CSV or JSON or API for that matter, whatever format you access data is ready calibrated data. Of course, you have an option as well within the platform infrastructure. If you choose to get uncalibrated data, maybe you want to do some validation, you can also do that. But the default setting is such that the data access is the last part after all the process being implemented.
Thank you very much, Dio. Do we still have time for another comment or question? Yeah, we still have 6 minutes. Okay, great. So I would like to emphasize as well some comments from the talks that we just heard. A very interesting point is the fact of knowing that in the future we'll have these hybrid networks of sensors that are low cost and satellite sensors as well. And this will increase the spatial and temporal resolution of the information that at some point we'll have to manage and process as well. So I believe that this future is perhaps already here. I don't know, Armando, if you could comment on that. How much is this hybrid system being used so far as part of some cities and as part of some governments, perhaps? Would you care to address that point? Thank you for that comment and question. Yes, so it is true that in some areas in Europe and the United States, this integration of platforms has started. They are integrating this to global models, so the resolution is increasing. I believe that in very shortly, we will start seeing some temporal and spatial resolution for air quality data, practically, we will be able to see in real time the level of some pollutants. I believe this is a very, very interesting project. For those who have been working in this type of work for the last decades, I believe that the future will meet many of our dreams that we had a decade ago. So there are several criteria as well that need to be taken into account. If we want to move forward in terms of analysis, we need to use atmospheric chemistry into the analysis. If we want to expand as well the monitoring, we need to also understand what are the components that we can add. So it is great to have this criteria, but once this technology actually provides more data, the data that we want, I believe that all of those who belong to the Global South, we will be able to move and take the next step in order to implement much more effective policies for air quality control. Thank you, Armando, for that comment. Yes, this really opens an array of different possibilities when we have several measurement systems available. Thank you, Armando. The last question would be for Olivia. Thank you very much, Olivia, for your presentation. You provided a lot of information in terms of air quality assurance data and accreditation. So what I can take away from your talk is that you need to do all of these audits and accreditations using the EPA as support in the United States. So do you believe that in Mexico, there should be a reinforcement in terms of the legislation around control and quality assurance of monitoring networks? Yes, definitely. I can tell you that the only document that we have is the 156 standard to create this quality system, which is based in 3 documents that were published by INEC, these 6 manuals. But everybody tells you that you need a monitoring plan, you need control strategies, you need control and quality assurance programs, but no one tells you how to do it. So these are many of the uncertainties that we need to work around in terms of the data. So that is why the EPA model that we are using, just to be honest, I believe that this is a very good model because it has a lot of information that complements the air quality data that we have in Mexico currently. But we still have to build this documental infrastructure to strengthen our monitoring systems and not only build it, but actually prove that it is actually efficient. So as I said before, we have an audit by Profepa, which is the institution in charge of doing that. I believe that the agency that should audit the monitoring systems in Mexico should be INEC by means of, it should be the INEC. So in order to understand what is the deviation of the data, we need to work with them because they have the competence to do that. And in any other case, we can always go to an external consultant if it comes to that, so that this external consultant can tell you what is the deviation of your data. Thank you so much, Olivia, for that. I believe that this is a common concern that we have. We need to reinforce the legislation in Mexico around these issues. There is a very specific question that we have for Bogotá in the pipeline here, but I would love for us, maybe Olivia, would it be maybe possible to have a meeting with Bogotá specifically in terms of quality assurance? They have very specific and punctual questions for you that we will not be able to address right now, but I would like to propose that you meet with them afterwards. Would that be possible? Yes, thank you so much. Thank you very much, Olivia. Okay, so I think that this was it in terms of the questions. I would just like to end my intervention here, repeating what has been said several times by the different members of teams that do routine measurements and research measurements, which is that low quality measurement that are non-reliable are more expensive, are more costly than actually carrying out a good measurement. And we know that it is actually quite expensive to do quality measurements of air quality. So that is why we have so much emphasis in having this quality assurance programs for reference and for the sensors, which we see big possibilities for those sensors. But we need to really make sure that the data is good quality data to answer the questions that we have in front of us. So thank you so much to our panelists for your excellent presentations today, and we will continue with our program. Thank you, Ceci. Thank you, Tania, Dio, and Armando for this discussion period. Now, let's move on to our experience exchange by members of the community of practice. I will now pass the floor to Freddy Grajales, who works as a technical specialist at the Environmental Modeling and Information Center, Ministry of the Environment in Bogotá, and also Juan Manuel Pérez. Freddy, if you'd like to start, I understand that your presentation is quite dynamic, so please go ahead. Hello, good morning. Can everyone hear me? Yes, yes, we can. Can everyone see my screen now? Yes, yes, we can see it. Okay, so the idea here is to just provide a picture of what we have been developing in Bogotá, as Armando and several other panelists have mentioned in terms of how to complement air quality data. Now, generating this data in a hybrid fashion with the reference system and the quite robust monitoring system that we have in Bogotá that is carried out by 20 monitoring stations alongside the microsensors that we are studying. So this program is called a collaborative network of microsensors for air quality, and this includes common citizens. We'd love for common citizens to participate, and we are now training some people to do this. So the idea for me right now is to just show what are the results in the way that we have been generating this data so far. Let me just start off by saying that we have a couple of phases here. Starting from 2021, 2022, we started comparing the data from microsensors. We were very interested at the time to analyze commercial sensors that were in the market and to analyze how this information was in terms of quality to be used. We are still in this process, and the idea is for now me to share that experience. Now, we are also creating an interactive platform for data visualization. We are downloading the data of each of the commercial platforms, and at the same time, we are creating a visualization mechanism of this data. The idea behind this is to be able to install different capacities of monitoring in micro environments so that we can actually make some decisions around air quality in the city. There is a model that we have been doing statistically, and this requires the adjustment and correction of data for microenvironments. And the fifth piece of this is the visualization for users to have this experience in terms of knowing how the sensors are performing. These are just very quick illustrations of those microsensors that we are using and evaluating. We used these 7 brands: AlphaSense, Blue Sky, Davis, Purple Air, the U Central here in Colombia, Smoogie, Clarity. These are really quick photos of these microsensors. And this is the Clarity one, which has communication, autonomy, and energy. The comparison procedure is actually done in one of the reference stations. Sensors are here in the upper side of the station. There are some photos here that you can see. This is the samples that are taken. This is the comparison, and these are the microsensors all around the station. So this comparison is being done in the station itself. The idea is to show you what is the process that we carry out for this. This evaluation, this assessment has taken 3 different time periods. The first one is from December 1st, 2021 to the 28th of February, 2022. The second period is a period in which the concentrations in terms of transportation are relatively low. And the whole period would be July to February 2022. Now, we will carry out this assessment for PM 2.5 and also PM 10. And this is very interesting for us because in terms of emission reduction and suspended particulate, we are very interested in PM10 as well. So for us, it's very interesting to carry out these both assessments. And that is why we started doing these assessments for other pollutants. Now, let me show you what has happened in recent months. We have here in 2018, 23, an average of 20 micrograms per square meter. We have a 6 standard deviation and 30 variation coefficient. This is being done under the framework of EPA. Armando was talking about this just recently, which is the guide that in 2021 EPA issued. Now, very quickly, let me show the process that we have been using. Each of the sensors provides data and statistical information, and in this way, we go in and evaluate the process. What we have been doing is to do an EPA score that has 7 criteria. At the end, the standard deviation and the coefficient is taken as 1 data, and the quadratic error is taken into account as the second data. So we see that the reference station has 100 points, and from there on, all of the different stations have a different one. And we have a problem here in terms of draws, right? So same scores. And on the one side, we thought it was quite interesting in terms of what would be the statistical distance or the similarities regarding these reference stations that we have in the microsensors. So as a proposal, we have the Bahala Novis station, which is similar to the Euclidean distance. And I would not like to go into detail here, but I would like to evaluate the distance here, and we can see the differences that we have been evaluating here. So we have the PUR1 and PUR2. So something that I didn't mention is that we are assessing by duplicate every station. And this is an equivalent of saying that we have an 82% of similarity of data between this sensor in comparison to the reference station, which of course is 100 points. Now, something that we did afterwards is to rank them in terms of the distance and the EPA score. If it meets the EPA criteria, that's how we assess it. So the range at the end of the day ends up being the value that we need to take into consideration, which is the range between the similarity between the distance and the EPA score. This has been done per sensor, but at the end of the day, we need to decide on the brand. So we did an assessment per brand. This information is not specific to the sensors, but this information is actually put in the same bag, analyzing the statistics per brand. In this way, we have an EPA score per brand and a distance per brand and a general ranking per brand as well. At the end, we have a comparison of PM10. And given that we have very, very short time left, let me just show this final screen. We have a summary of the main statistics of PM 2.5 have better quality values than PM10. in terms of the first and second quarters and the full period, which have different criteria in terms of sensors. We have evaluated other criteria like the platform, the installation, and at the end, we have evaluated the three criteria: the ranking PM 2.5, ranking PM 10, and the data of the various platforms to our servers. Installation processes as well that are a little bit more difficult to install, and the cost is also something that is quite important for us in terms of the microsensors network. At the end, we have a general score, and that is how we are evaluating microsensors in our comparison. That would be it on my side. Thank you.
Muchas gracias, Freddy, por acompañarnos desde...
Thank you so much, Freddy, for joining us from Bogotá. So now continuing with the Latin American experiences, we now have Juan Manuel Pérez, who is Performance Indicator Analyst from the Ministry of Environment of Territorial Development from Guanajuato State, and he will tell us about the quality control and assurance systems in the state of Guanajuato. So please go ahead. Yes, thank you so much for having me. Thank you so much, everyone. So can you please help me just projecting the next slide? So basically what I would like to tell you about is what is the context of our network. And as it has been mentioned by other panel members, every network is different. And what I would like to show you is to give you the context of Guanajuato so that we can start talking about the challenges. So the state of Guanajuato is in the central part of our country. We have a semi-arid weather. We have around 6.1 million inhabitants. And something important too is that we have 1 million motor vehicles, and we have 46 municipalities. Something important to highlight about our state is that we have a significant economy nationwide. We have a sixth place in the economy level. And within the considerations that we have is that agriculture is predominant in our state. However, we also have other important sources such as oil refining, also power generation plants, and we also have other artisanal processes such as footwear. We also have the case of clay bricks done in our state. However, they remain being artisanal or handmade. And we also have a food industry, which is really important in our state. But an important part of our state dedicates to agriculture. So we still have that contrast. On the one hand, a lot of agriculture, and on the other hand, a heavy industry in our state where we have an oil refining and also a power plant. And in the next slide, what we can see is the way our network is distributed. Something important to mention is that the objective of our network is what people are breathing. And we're generally not monitoring sources. Some people ask us, how are brick manufacturing companies are polluting and other sources as well? But what's most important is what is the population breathing? And in this aspect, what our stations are doing is that they're based where the highest density of the population is located. Something that we need to mention is that we have 18 stations in 10 municipalities, and these 10 municipalities are around an industrial corridor where we have most of the activities happening. And also most of our population is located there and around this industrial corridor, and it covers around 60% of our population. It is also worth mentioning that we have one data analysis center. We have maintenance and calibration workshop and laboratory. And because of our nature, since we have a oil refining center and a power plant, we are actually working on this because in the Salamanca municipality, we have an industry that can generate other contaminants that are not regulated in our Mexican regulation. However, they do represent a public health problem, and they also represent a problem in terms of credibility in our network. And I would like to tell you a little bit about this, because despite us having the best quality controls, the best assurance systems, also the citizenship perception plays an important role in the credibility of our network. So let me tell you a little bit about this. So what we'll see on this slide is the operating diagram of our network. So we make sure that different institutions are within the operation of our stations, and that we have different organizations involved in order to provide certainty to the network. And what we can see here is that we are looking for the operation of our stations is done by local governments, by municipal governments. And an important piece of information I'd like to mention is that out of our stations, the furthest away, or the furthest one, is around 216 kilometers away, as opposed to what Olivia mentioned, that Mexico City has a lot of their stations concentrated in a 32 or 30 kilometer radius. So we have a broader coverage, and the time of commute between the furthest stations, it's around 3.5 hours in average. So that makes it difficult to have a good logistics, and that's why we're looking for local governments to also play an important role in this. So we have made a way to make the information transparent and to have this accountability scheme where we provide supervision through universities. So we give them the procedures that we have in the Mexican legislation available. We train them, but they're the ones who are making sure that the operation and the information we have is appropriate. Somehow we are giving the importance to the population for them to give us feedback and also to support us. And what we do as a state deals with calibration, maintenance of equipment, and also the validation and the publishing of data. There are some stations that were still operating, mainly in the areas where we do not have the backup from municipal governments. And we also try to absorb that, but at least we try to have the fewest municipalities in this situation. And on the outside part, we also have some audits, as Olivia was mentioning, that are done by Profepa in a documentary way. But we also look for other accreditations from some other entities. In our state, we have worked really well with the standard ISO 9001, the 2015 version. And even though this is an administrative standard, it has helped us to manage our risks, which is actually where we will talk about the challenges we have. So if we go to the next slide, we will be able to see which have been the main challenges we've faced. And I've mentioned that a monitoring station is practically a laboratory with all the controls that it needs to have for temperature and humidity, as well as other controls. But we have seen some, in our risks analysis, a lot of opportunities in other situations. And here we will see some images regarding this. So let me tell you very quickly which have been the hardest challenges that we've faced. I'm sorry, time is up. Okay, just let me speed up. So we have seen a lot of challenges in the external services. One of them is the power supply. For you to have an idea, one of our stations goes around 2,500 kilowatts per hour, which is a high energy consumption. And the consumption of AC is actually really, really high. We have a really hot weather here. And these external services are really necessary for the equipment to function properly. A monitoring device is really sensitive to all of these variations, both from voltage and temperature. They may cause some issues. But I would also like to mention something really quickly. The pandemic also hit us hard. A lot of our stations are located in hospital centers. And during the pandemic, these centers, well, were safeguarded by the army, and all the quality and assurance control systems and programs that we needed to do, we were not able to do them because we had no access to the stations. And something important too is the staff turnover in local governments, as well as all of the training of the operators has been something important. Another restriction that we see is, as we mentioned, in the infrastructure that we have in Mexico, we only have a single ozone standard, and also the possibility of sending all of our calibrators to this national standard is quite restricted. And as it was also mentioned by other of my colleagues, the budget is also an issue. So finally, what have we done? We'll see in the last slide that what we have been looking for is, by making this risk assessment, we have tried to really automate all of the operation. We're developing some apps we can access remotely and turn on and off some equipment as well as ACs. And also the operators can enter all of the information there so that we can somehow have some trends in some voltage variations and in other internal components. And oh, I'm so sorry, but time is up. Okay, so just let me conclude. So what we're really working on is really updating our network, updating our equipment, also the renewal, and also looking for financing through environmental funds. So that's all I wanted to share with you, and I really thank you for having me. Thank you. Thank you so much, Juan Manuel. Okay, so next, as the last speaker, we have Claudia Bárcenas, who's the quality consultant, and she'll be sharing with us her experience with an external entity. Claudia, you have 5 minutes, so please go ahead. So let me tell you really quickly about my experience in the operation, control, and assurance of quality through an entity external to the government. So here in this slide, we show the main struggles governments face when operating monitoring systems with what they can be done by an entity that is outside the government. So most of this has to do with the organizational structure. We lack a specific structure. And we also know that in the monitoring systems, there are 3 specific areas: maintenance, calibration, the analysis of information, and also the publication of data. So by lacking a specific governmental structure, then in these 3 areas of we need to have staff that is well defined and trained with the appropriate profiles for them to perform their roles and duties, even though sometimes the staff members perform other activities and not only support the monitoring systems, but they also have other activities that they need to develop. And on the other hand, in operation and maintenance, sometimes there's a lack of budget for consumables and spare parts, which are essential in order to ensure the appropriate functioning of the monitoring devices. And as soon, or we also have a difficulty where they need to go through a process of the acquisition laws that they can actually purchase or get whatever they need to operate the systems, and that delays the response times for addressing any failures they may have. And of course, that this has an impact on the percentage of validated data and the non-compliance with what the standard is mentioning, which is 75% of validated information. When it comes to analysis and validation and publication of information, so probably not so much for procurement, but sometimes there's a lack of the appropriate infrastructure of IT systems that allow, as it was mentioned before, to automate some processes in order to have an almost real-time publication and making sure that the information is pre-validated for the information that will be going out to the public. And then is having a specific structure in order to operate them and having trained staff that could perform each of the duties. It is worth mentioning here in the specific case of Querétaro, where we have had the experience of supporting them in each of the areas of the system, is that first of all, we were able to characterize and do the re-engineering of the entire monitoring system. Some stations were relocated, the renewal or replacement of some devices were done. There was a laboratory that was installed, and there's also some internal and external audits being conducted. And of course that we're complying with a percentage of validated information, percentage, which is over 90%, and all of this with a commitment for the network to be operating in the optimum conditions. It is worth mentioning also, talking about an advantage mentioned by Juan Manuel, with regards to the resources. Sometimes the budget is taken from the operational expenditure because we need to budget this both for the staff members and also for the operation of the network. And sometimes this is a very limited resource. However, if we see this option of hiring a third party, then there may be a project that can actually be included in an environmental fund and being able to get resources for a specific project that strengthens the operation of the system. I would also like to mention that what is being foreseen is that obviously we will not be hiring a third party forever, but this will also be an opportunity for the governments that have a strengthened network. However, as Juan Manuel mentioned as well, sometimes there's a staff turnover and there's a dynamic of the governments, 3 years local and 6 years state-wise, where there's a third party coming in order to strengthen the monitoring network, and afterwards they just leave the staff trained so that they can keep operating it from the governmental side. So on that end, what was done in the case of Querétaro was that the operational continuous staff members were hired locally, and by having some external consultancy, they provided the training so that at some point when the government decides to continue with the operation of the system, they can have the appropriate local staff members so that they can operate it in all the areas that make up the system. So overall, that's what I wanted to share with all of you. And I'm open for any question you may have. Well, thank you so much, everyone. Thank you, all the panel members. Unfortunately, we will not have any time for exchange of opinions and comments, but if you have any comments or questions, please just send it via chat or via email, mention who is addressed to so that we can address this. And just to wrap it up, I would like you to turn your cameras on so that we can take a group picture, because now we are all allowed to turn our cameras on to take a group picture.
Muy bien. Pues muchísimas
Okay, great. Well, thank you so much, everyone. Thank you so much to all the speakers, and thank you so much, everyone, for joining us. Hopefully the presentations have been really important for you and helpful, and we hope to see you soon in our next session. Thank you so much once again, and have a good one.